Professor Gavor. I apologize for not having the video done right the first time, which is the goal of everything in operations. Do things right the first time. If you don't, you end up doing it over and over again. And today, this is like my fourth attempt to make this video. I got a phone call in my second one. Another video on my computer popped up and started talking in the third one. And so this is my fourth attempt. Here is the data that we have. We have a month, 2 years of data, and we have some actual data. And we're interested in forecasting into the future, but we use we're going to use this actual data to see how our forecast works. And what's the first thing we're going to do? We're going to do a 3-month moving average. And I will make this bold. I'll make the font maroon, and I'll make it bigger. I'm a creature of Excel habit and always try to label things the same way. So we have our 3-month moving average. So obviously I had already taken this cell and made it wrapped and bolded. Now, to have 3 months, we have to have 3 months of history. So I can't do a forecast for this 1st January because there's no months of history. There's only 1 month of history here, only 2 months of history right here for March. So it's not until April I can make my first forecast. So what I'd like to do is I'm going to go here and block, gray this out a little bit to show that, we're starting in April. And I use my Excel function average. And it gives you the average of the numbers inside the parentheses. In this case, I just highlight the 3 numbers that I want, and it says B3 colon B5, which means all the cells inclusive starting at B3, ending at B5. So I get the 3 that I want, and it gives me my 111. So it's giving me an error here. What's the error it's giving me? It's saying formula omits adjacent cells. Ignore error. Let's get rid of it and see if it hopefully does not pop up again. It might because, yeah, it does because Mac Excel is just a little different. There's all my data. Now, I want to see how accurate, and I get a forecast right there. 177 in January, which I think we got in both classes. The next thing I want to do is what? Absolute error. Then I want absolute percent error. And I want squared error. And I'm going to do all 3 at once. So again, I'm starting here in April because what is my error? My absolute error is ABS for absolute value equals ABS. And then it says absolute value, and if you click on it, it says, you can always look at it, it says, returns the absolute value of a number. The absolute value of a number is the number without its plus or minus sign. And the argument, the number is in between the parentheses, but I can also do a calculation. So I want to take my actual, so I click on that, 99, minus the 111, which is the 3-month moving average forecast, put a close parenthesis, and I get this 12.133 forever, but I'm going to just move it down to 1 decimal place. And I copy it down. But I don't want to. I can't do it in January because that is the future. The third year of January is the future, so I can do that. What is my absolute percent error? It equals my absolute error divided by the actual expressed as a percentage. And I go up here and just click on percentage, and I'm going to add 1 decimal place. And I'm going to calculate that down. And again, I'll get rid of the January in the beginning of the third year because there's no actual to compare it to. And then what's my squared error? It's equal to the error. And how do we square it? It's the hat sign above the 6 key, so shift 6. And then it says everything after that is going to be an exponent, so my exponent is 2. And I get this big number. Again, I want to reduce it to 1 decimal place. And right size this to what? About the size of the other ones. And copy this all the way down. There we go. So now I want to take the average. Absolute error to get mean absolute deviation, mean absolute percent error, and mean squared error. I've just put an m in front of absolute error, an m in front of absolute percent error, and an m in front of squared error, which stands for mean, which stands for average. That means I want to take the average of these individual errors. So I just want to take the average here, equals average, boom, of that. And it filled them all. No, it didn't. It populated, but not with average. So now, as those aren't averages, I want to push these over, and I get 364 for my MSE. I get 15.9 units for my MAD, but I get not as a percentage, so I want to make it a percentage. 13%, 13.1% for my MAPE, my mean absolute percent error. I want to make it bold. And what was my color coding? I think we used green, yellow, orange. This is just my way of how I look at it. And then probably I want to box all this stuff in to make it look pretty. In case I want to copy and paste it into a PowerPoint, I would have to get rid of all these error things. Ignore error. Good, I got rid of them, it looks cleaner. Now the last thing I probably want to do was probably the first thing I should have done when I did my forecast, but let's look at the 3 months. And let me graph this. So I go insert, recommended charts. I like the 2-line graphs like this. Okay. The blue is the actual sales. It has a lot of zigzag. The orange is the 3-month moving average. And you can tell it moves more in the middle, and it's smoother than the jaggedy, zigzaggy of the original data. It's because we're taking the average. It's never going to be an extreme value, and it's going to react slowly. Here, it's doing okay while it's kind of flat. The actual is kind of flat, but when the actual picks up, it takes one month for it to decide, oop, it's going up, and start following it up. And then it comes abruptly down, but we go down minimally and then follow it up again. It peaks out here, but we peak out maybe here. The next month is probably going to be down lower because it lags behind, but it's a decent forecast. What does this say? The MAD is saying our average forecast is off by 16 units. All right, is that acceptable or not? And is that 16, if we're forecasting in thousands of units, that would be 16,000 units. So if we're making something like a consumer product where we're making, on the like 150,000, 170,000, to be off by 16, is that okay? Well, it depends how costly the product is, and if you've got inventory to cover these variations in sales, it's probably okay. I would think that kind of small error is reasonable. It's 13% error. And of course, the MSE is a squared error. It's like a standard deviation. I'd have to do another forecast when we do what we'll do next is exponential smoothing. When we do that, we will compare and see how it works. So this is what? 3-month moving average. It looks visually pleasing, and the MAD and MAPE, which is our primary way of looking at this, I think look good to me. Unless the items are very costly, I can live with this kind of error for most consumer products, I would think. So we want to do it again. But this time we want to do what? I want to copy these two columns right over here. Boom. But instead of 3-month moving average, I want to do exponential smoothing. With alpha equal to what? Let's say alpha is, we'll do 0.3 like we've been doing. Okay, and I put my alpha there. So now I want to do my exponential smoothing. Exponential smoothing. Now we can do more here. Again, I probably want to make these wrap the text, right justify, make it bold. Oh, I forgot to do this too. I probably want to, being the creature of habit, again, I'll probably like to highlight them in blue. Starts to look pretty. I probably want to copy these over here because I know I'm going to do the errors for this exponential smoothing. And now it's time to do my actual exponential smoothing forecast. Once I do the forecast, I can draw the graph too. Remember, I can do exponential smoothing. I don't need history, but I do need a sales and I do need a forecast. So exponential smoothing forecast. There is no forecast in the first row. So we said we're going to seed it. And I was going to use 115. I'm just making that up. It's a seed. It's to get it going. And I make it red to remind me that's not an actual forecast. It's a made-up forecast to seed this. Now I can do my forecast here. What is the formula for exponential smoothing? It equals to alpha times the previous actual plus, parentheses, 1 minus alpha, which will in this case be 0.7 every time, times the previous forecast, our seeded forecast. And I hit enter. There we go. So let's make them 1 decimal place each. Okay. Now, I want this alpha to be constant. If I drag this down, I'll probably get an error. Because if I look at what I'm trying to do here, if I click on this, it's not using alpha. It's using, it moves everything down. From here, if I look at it, it's using alpha and the two in the previous actual and previous forecast. But when I dragged it down, it's dragged down from 0.3 to this cell. But I want to keep 0.3 the same. So what I want to do, go back here, and I want to nail that cell down. How do I do it? I put $ before the P, which is the P1 cell is alpha, and a $ after. The $ before, if I want to drag anything left to right, it keeps it on the cell. And the $ after the P says if I want to drag it up and down, it keeps that cell fixed. So I put $ in both cases. Probably only need the $ after, but that's okay. So let's focus this down. Let's take this down and I'll get my January forecast. So it's 166.4 as opposed to what was it before, 177. Now, I've got it set up exactly the same on purpose. I got my actual and I got my forecast. So here's my 3-month moving average forecast. Here's my exponential smoothing forecast. So if I copy my absolute error, my absolute percent error, and my squared error and bring it over here, and just say copy, or I didn't copy it, I just highlighted it and didn't do anything. Copy, as I'm copying it, Control C, and I got the dashed lines, and I say Control V to paste. And now if I look at it, it takes the absolute value of exactly what I want, the actual sales, and this. If I look at the percent error and do it, it takes the absolute error and divides by, did I divide by the wrong thing? Could I have possibly done that? Yes, I divided by the 3 months. I got to divide by the actual. So let me do that again. Let me highlight this and move this to where it should be. And now let me drag all these down, and it changes it to 12. Okay, much better. So let me copy this properly now. Okay, I'm going to copy it again, and I'm going to go over here. And let's look at that 2.2. It will change to something else. It changed to 2.3. I copy these. Oops, I don't want to put it there. I want to move it back where it was. Let me do undo. If I made a mistake, undo it. Okay. Go away. And I don't need this last row because I want to copy these. So I want to take the average equals average. Now I'm taking average of everything here. And if I move this average over twice, this I have to make a percent again, and I make it to 1 decimal place. Good for me. So let me box all this in. Let me make this green, yellow, and orange. Those are my forecast errors. Which one is better? Look at my MSE. Now I can say that, ooh, this is 428, this is 364. So 3-month moving average is better than exponential smoothing with alpha equal 0.3. So let me graph this. And I'll graph it all the way, including the forecast. And let's say insert recommended chart right there. Let's put it right here, and we'll put it next to the exponential, the moving average one. So this is exponential smoothing. Boom. Here's the magic. I put the alpha rather than the formula. I can change the alpha whenever I want. What if I change the alpha to, as we did in class, let's change it to 0. We get a flat forecast where everything is forecast as the previous forecast. It just becomes 1. Well, that's not a very good forecast. And look, you got 20% MAPE versus 12% here. Let's make it equal to 1. Well, now I get a zigzag. I get the exact same curve, but shifted over 1, because it's just saying now my forecast is my previous actual. 13.1, 13. If I made these one decimal place, it'd be exactly the same. 99, 99, etc. So let's make it 0.7. Well, now my MAPE is 12.2, 15.8, and 370. How come the MAPE is higher here than this, but the MAD is smaller? Because I'm taking percentages. The percentages are depending on, are my errors where the percentages are the biggest or the smallest. It's just the way the numbers come out. So we made it 0.7. We should make it 0.5. See what that does? Oh, now my exponential smoothing is superior at all points. 0.6, does that make it better? How about the same? 0.4, it's about the same. I think 0.5 is probably the best. Oops, look at it. I changed the title, so let me undo. When I make an error, I just undo and it fixes it. I go here and say 0.5. Okay. And let me put these in the same powder blue color. So there we have that. So there's my two graphs. There's my two tables. Let me get rid of this. Now what could I do? Well, I could do regression, couldn't I? Of course I could. That's what we want to do next. In fact, I think I'm going to copy this whole table. Really? I'm going to copy the whole table? And let me put that right there. Oh, no, I didn't copy anything. I didn't hit control. I highlighted it, but I didn't copy it. Let me copy this. Copy. Now it's copying it. Now I do place it there. So let's look at this. I want to get rid of my forecast, but I'm keeping everything else the same. And it's still calculating a MAPE and all that, but I think I also want to put something, copy. It's always going to be, my absolute error is always going to be 100% off because my forecast is 0. The error is always going to be 117 minus 0, 113 minus 0 to one decimal place. You know, there's hidden decimal places here. So now if I put my forecast in, if I put my linear regression in here, see, I'm lazy. And, you know, lazy is a good thing. There's linear regression, and we want to use linear regression here. And there's no alpha, so we can delete that. How does linear regression work? I copy my but I got to be careful. Remember, I want to use X has to be numbers, so this has to be, we can't use January, so let's use 1 for January and 2 for February, etc. What do I do when I get to the next January? Is that 1 again? Well, January's tend to be the 1, but in this case it would be the 13th month. So what I want to do here is say equal to the cell above plus 1. Now if I put my cursor there and double click on it, it takes it all the way to 25, and I want to make it 26 because I can forecast farther into the future with regression. I can only forecast one period in the future with moving average or exponential smoothing. All right, so I have my data. Let's highlight this, and then let's insert a graph because we're using graphical method, the very easy graphical method to do this. So let's take this one. I'll put it right here so I can compare my graphs easily. This is a little bit more compact than we did in class, so you're not scrolling all over the place to compare things. All right, what do I want to do? I'm going to click on a graph. If I'm not on a graph, it just shows the normal menu. If I click on a graph, it gives me a graph menu. I can change my graph to look like that. I can change it black, and everybody changes it to whatever they want. I'm very simple about this. But I want to go to Quick Outlook, and there's many ways I can look at data. I can look at my graph like that. I can go to Quick Layout and look at my graph like that, where it makes all the numbers. It's hard to read. The one we want, though, is the one that says fx right there. And that gives me my equation. I don't need my legend because I know that the blue solid line is the actual and the dotted line. So this is what? My x is what? Months. Month. This is, if I want, sales. And we never said if it's sales in dollars. And this is linear regression. Okay, and here is my numbers. I go home. I usually like to make them bold. I like to make them maroon too, and I like to make them a little bit bigger so I can read it. So it says the R squared, coefficient of determination. Reading that as a percentage is 0.6538 or 65.38%. That's the amount of variation in the Y data explained by this model. I'm pretty happy with 65%. So now to get my forecast in linear regression, what do I want to do? I want to say it's equal to, it's still red, we'll turn it to a different color in a second. I want to multiply the slope 3.6306 times the month. That's the x value. Plus 84.355, the y-intercept, 84.355, and hit enter, and it gives me 88. Now you see that in each case, so let me make that black because it's not a seed number anymore. It actually is a forecast. So I'll make it automatic. And let's just drag this down one. Watch what happens to the errors in that row. They change. So if I bring this all the way down here, it makes my MAD 14.8, my MAPE 12.1, and my MSE 311.16. This is the best by MSE. It's not the best by MAPE, and it's the best by MAD. So that's good. If I want to do a forecast, I can extend it down 2 more, and it will give me my forecast. Now, each forecast goes up by 3.63. This is the pluses I can forecast. I can take to month 26, to month 36, to month 52. I can forecast as far into the future as I want. The downside is I'm committed to a linear model where it says every month is going to be 3.63. The forecast is going to be 3.63 units higher than the month before. So that's the downside. It's not if the stock keeps going. I mean, if the sales keep going down, this is merely going to keep going this way until I recalibrate and redo the regression. Maybe don't only look at the data now where it's going down. The plus and minuses of these other methods are they adapt very well to the zigs and zags. The downside is I can only forecast one period into the future. Now, this helps you answer question number 4 on the worksheet. That's basically what are the advantages and disadvantages of these two systems. Moving average and exponential smoothing are kind of in the same boat. Only the negative is that they only forecast one period into the future. The positive is they adapt pretty well to if there's a lot of undulation and movement in the sales. The regression only commits us to a linear model, but I can forecast out forever. But that's a positive, forecasting out forever. The negative is that I'm committed to a linear model. This line is going up all the time. Or if it's a downward, if sales are going down, it would be going downward all the time. So basically that's it. When I post the video, I will post this version of the video. Here's the morning session, section 1 that we did. Here's the afternoon sessions, section 2. And then I think this one is the best version of all, where it's more compact and we did the video in a short period of time. Thank you very much, and we'll talk to you on next time we're in class.